Okay, so the first sequence, we notice it's going up by 4, up by 4, up by 4, up by 4. So you might be looking at this and think that, well, this is just a linear function. But instead of thinking as y equals mx plus b, we'll think about it as a of n equals. And so we want to make sure that as we write this rule, that whatever we make in a table makes sense for the terms 1, 2, and 3. So a big difference on this rule is that we don't do y-intercept. If we did the y-intercept, that would be the 0th term, and that doesn't make sense. We want this to be the first term. And the easy way to handle that is just to say, well, if this is 4x plus b, well, what must be over here? And we'll just go back 4, so negative 10 would work. And that is just fine. 4n minus 10 is an explicit rule. The other option, of course, is just to kind of work with the term numbers. You could say that it's going to be 4n minus 1 plus negative 6. And well, why would I do that? I want to make sure that this is the first term. And so if I want that to be the first term, I don't want to add 4 yet. So 1 minus 1 means add 4 0 times, and I would start at negative 6. So that would be that first sequence. Either one's fine. I personally like this, but this is what you'll see in the textbook a lot more. This guy, on the other hand, you probably notice that as you go along, it is multiplying over and over and over by the same amount, times 2. So we might say that this is exponential. We might be thinking y equals ab to the x, but instead we're going with a of n. Same challenge. I want to make sure that as I use a table that the first term is 3. So an easy way to do that is to say that I'm going to do 3 times 2. And instead of saying 3 times 2 to the x, I'll just say to the n minus 1. That way I haven't multiplied by 2 yet for the first term. I need this to be the first term. So there you go. What are these rules called again? From your previous class, we call this arithmetic. That's an E. And over here we call this one, instead of exponential, we call this one geometric.